Margin of error, sampling, and bias notes. So this is one of my more favorite sections because you can really apply it to real world stuff, and you can really apply it to what you see in the news and data that's displayed, and it really helps you understand like what's going on. And especially now with all the data that's being thrown around with election stuff and coronavirus, and you can really tell and be able to see and know like what's good data and what's bad data. Okay, so let's start off with margin of error. Now, this is a real basic formula for margin of error. You will learn in Math 3 and get a more, a more specific version of margin of error, but I want to give you a more basic version just to kind of give you a glimpse, especially with all the talk about the election, and how, and like when they talk about margin of error, of kind of what they're talking about, so you have an idea. So margin of error is a cushion around a statistic. The larger the margin of error, the less confidence one should have about the poll that was taken. So the formula for margin of error is 1 over the square root of n, where n is the sample size. So for example, if you poll 1,000 people and ask who they will vote for president, 500 say they'll vote for Trump, while 450 say they'll vote for Biden, and 50 chose not to answer. So 500 out of 1,000 is 50%, obviously. 450 out of 1,000 is 45%. So would you think that overall Trump leads 50% to 45%? Or would you think that overall Biden is down 5 points? Well, you only sampled 1,000 people. Even if you picked a sample that was a perfect representation of the population, the outcome might not accurately reflect the population. There will be some error. So, you really want to sample a large amount of people. You want to sample a large population. That is the key when you're doing a poll. So the main takeaway from this is in statistics, you can basically get your poll or whatever it is that you're trying to prove. You can kind of get it to say whatever you want to say, and we're going to talk about that the more we get into these notes, based on like when we get into bias, based on how you answer the question, the type of population that you survey. You can get statistics to say anything that you want to say. So there's good statistics and there's bad statistics. So if you want a true representation, there's a good way to do it, because there are good statistics out there. There's also bad statistics out there because unfortunately people lie because they get things to say what they want it to say, because there's people out there with bad motives. There's also people out there with good motives because they want to know the truth. So finding the margin of error. So suppose that 900 American teens were surveyed about their favorite event of the Winter Olympics. Ski jumping was their favorite of the 20% of those surveyed. This result can be used to predict the proportion of all American teens who favored ski jumping. So the way that we would find that is we would do 1 over the square root of 900. So you would just type that in your calculator. 1 divided by the square root of 900. So that would come out to be 0.033. If we change that to a decimal, percent, remember you move your decimal 2 places to the right, which would be 3.3%. All right, so find the margin of error if the population is 1,500. So you would do 1 over the square root of 1,500. So that would be 0.0258. Move your decimal 2 places to the right. So if we round that to 1 decimal place, that would be 2.6%. And anytime you want to try this on your own, just pause the video. Find the margin of error if the population is 20,000. So we'd do 1 over the square root of 20,000. So if you want to, you can pause to make sure you're getting the right decimal. So that would be 0.007. Move your decimal 2 places. So this is actually 0.7%. And find the margin of error if the population is 250. So 1 over the square root of 250, which would be 0.06. So the margin of error is 6%. 25%. So the smaller the number, the larger margin of error you're going to have, which means like basically the further away from the truth it's going to be, or the larger, the larger of errors you're going to have. Okay, so let's rephrase the question a little bit. If you want your margin of error to be 2%, what size sample would you need? So this one we would set up. So first of all, change 2% to a decimal. So if you change 2% to a decimal, you would move your decimal this way. So it's going to be 0.02, and we're going to set it equal to 1 over the square root of n. Now, we want to get that off the bottom, so remember we'd move it up and over. And so that means now we would have 0.02 square root of n equals 1. And then we would basically divide by 0.02. And so now we get the square root of n equals 1 over 0.02. So long story short, when you're looking for the sample size, excuse me, when you're looking for the sample size, we can basically start here every time. So we can start right here, okay? You're going to start with the square root because you would be doing the same steps every single time. So you can start with the square root of n equals 1 over your percentage right there. Okay, so 1 divided by the square root of 0.02 is going to be 50. So the square root of n is going to be 50. Now remember, we're not done because we do have to square both sides because it's not just the square root of n. You got to get rid of that square root. So then we get n equals 2,500. So our population has got to be 2,500, okay? So then our next one, if we want our margin of error to be 1.5%, so remember, if it's 1.5%, move your decimal 2 places. So it's 0.015. Oops, sorry. So we have the square root of n equals 1 over 0.015. And so square root of n equals 66.67. And then when we square both sides, we'll get n equals 4,444. Okay. If we want it to be 4%, we have the square root of n. Remember, move your decimal 2 places to the left. So it's going to be 0.04. Whoops, forgot to do it over 1. So it's 1 over 0.04. So the square root of n is going to be 25. And then square both sides. So n has to be 625. Okay, so now if your sample size is 400 and you wish to cut the margin of error in half, what will your new sample size be? Okay, so first of all, let's figure out what the margin of error is when our sample size is 400. So 1 over the square root of 400 is 0.05. Okay, so if we want to cut that in half, let's divide that by 2, and that's going to be 0.025. Okay, so now this is our new margin of error. Okay, so now let's do the square root of n equals 1 over. And now we never turn that into a percent, so we don't have to worry about moving our decimal place. So that is going to be 40. And now we need to square both sides. So n is going to be 1,600. Okay. Okay. So, collecting data. So let's talk about how, if we refer this to the election or, even coronavirus, stuff that's going on today, let's make it relevant. So there are 3 ways to collect data. We have surveys. And so surveys, they most often involve the use of a questionnaire to gather info. All right, observational studies. Individuals are observed and certain outcomes are measured, but no treatment is imposed. So people are just observing what's going on. Okay, so surveys would be like they're getting your opinion about something. Observational studies, they're just watching what's going on. They're not asking your opinion. They're just kind of watching what's going on. In experiments, a treatment is imposed. So they may be giving you medicine, or they may see how you respond, like maybe study habits. They may be seeing how you respond to listening to music versus not listening to music. Okay, so that is some type of treatment. They may not be giving you any medicine, but they may see how you respond to listening to music. Okay, so something is being done to you. Okay, so let's look at some differences here. So 50 people with clinical depression were divided into 2 groups. Over a 6-month period, one group was given a traditional treatment for depression, while the other group was given a new drug. The people were evaluated at the end of the period to determine whether their depression had improved. So, right here, key word, they were given traditional treatment and then new drug. So since they are being given something, this was definitely an experiment. Okay? All right, so for B, to determine whether or not apples really do keep the doctor away, 40 patients at a doctor's office were asked to report how often they came to the doctor and the number of apples they had eaten recently. Okay, so they're not being told to eat apples or anything like that. They're just being asked how many they eat. So they're not being imposed or anything like that. They're just being asked how many they eat. So this is an observation. All right. And a teacher passes out a form at the end of the semester to see what learning methods the students liked about her class. So they're being asked about their opinion. So this would be a survey. Okay, so types of sampling. In order to collect data, we must choose a sample or a group that represents the population. And the goal of the study will determine the type of sampling that will take place. And this is where that information can either go good or go bad, because the type of samples that people collect can all affect like your information, whether they collect good samples or whether they collect bad samples. So a simple random sample. So all individuals in the population have the same, that is the key word here, have the same probability of being selected in all groups. And the sample size have the same probability of being selected. So here's an example. 100 names are being put in a hat and 10 are picked. So this would be a simple random sample. We often abbreviate by SRS. Okay, so 100 names are being put in a hat. A lot of times, if you get real specific, like for example, my AP Stats class, you would go as far to say as they're put on like equally sized slips of paper. Like I would get real specific with that, but since this is an AP Stats, we won't go that far. All right, 3 red marbles and 2 green marbles are put in a bag. 1 marble is picked. So initially you may think, oh yeah, sure, that's simple random sample, but actually it's not a simple random sample, because they are, let me slide this up. So they are not all are equally likely. Red has a better chance because there's more red. There's more red than green. So this is not a simple random sample. Okay, if it was 3 red and 3 green, then it would be. Okay, so that's why. Okay, a stratified random sample. So if a researcher wants to highlight specific subgroups within the population, they divide the entire group into similar groups or strata, then randomly selects the final subjects proportionally from the different strata. So a stratified random sample. So a researcher wants to study the lifespans of dogs. She divides the dogs into groups based on their breeds, looking at golden retrievers, poodles, boxers, dachshunds, German shepherds, cocker spaniels, beagles, and Yorkies. So this would be good strata because they're divided according to their breeds, and she's going to pick some from each breed because the breed could affect their lifespan. So a researcher wants to do a study on heart disease. He decides to compare people based on geographical location as shown below. Do you think his use of strata was appropriate? So no, not really, because maybe their geographical location has nothing to do with heart disease. So maybe we should divide based on something that has to do with heart disease. So based on maybe weight, blood pressure, or blood cholesterol levels. We want something to do with, heart disease, okay? Where they live really doesn't have anything to do with heart disease, okay? So, cluster samples, and a lot of people get clusters and strata mixed up. So, a researcher divides the population into groups or clusters, and a random sample of these clusters are selected. All individuals in the selected clusters are included in the sample. So here's the difference between cluster and strata. So cluster would be like, so over here, so I'm looking at this one right here, okay? So cluster would be like we take this whole group here and this whole group here, okay? And it's not really a good representation because we're taking like all the yellows and all the reds. All right, strata is better. It's harder to do and it's going to take more time, but it's better. Because strata, we're going to take these 2 yellow, we're going to take these 2 out of the red, and we're going to take these 2 out of the blue, okay? So here, we're going to watch a video real quick that explains strata, hopefully. I wonder if it'll let me click on it. Well, it's not going to let me take you to it. But there is a YouTube video. If you just YouTube strata versus cluster, and it divides Skittles. So if you YouTube that video, I highly, highly, highly recommend it. YouTube the video, strata versus cluster, and it's really short. It's like 2 minutes long, and it just shows like Skittles in some bowls. Watch that video, and it does a really good job of the difference between strata and clusters. Okay, so let's look at some examples of strata and clusters. So, a teacher groups students in the auditorium by the location of seats. Okay, so that would be cluster because it's easy to do. They're all grouped together. Okay, it's not by, so strata is going to kind of be, think of strata as like they're going to be together based on characteristics, and you're going to pull similar ones from each group. So you're going to get a little bit here, a little bit there. A researcher groups people based on weight, picks 3 people from each group to track their weight loss progress over 3 months. So that is going to be stratified because she's picking 3 from each group. A researcher marks off plots of land based on proximity through a river and tracks the growth of trees. That is also going to be stratified. And then everyone in Gatkin County and Ashe County is polled about the election. So that's going to be a cluster because you've got the two counties grouped together. So that's going to be a cluster. All right, a systematic random sample. The researcher selects a number at random n and then selects every nth individual. All right, so an example would be that, like, for example, Miss Davis. I didn't spell that very good. I messed up writing that. Miss Davis lines up the class and picks every fifth student to leave early. Okay, so a convenient sample would just be students are taken from a group that's conveniently accessible to a researcher. So an example would be selecting the first 50 people through the gate at a football game to take a survey. Okay. All right, a voluntary response sample would be, so this sample is made up of people who self-select into the survey. So often these folks have a very strong interest in the main topic of the survey. An example of these would be like a Facebook or Twitter poll, or basically anything on social media. All right, and then we get into types of bias. So bias occurs when a sample systematically favors a certain outcome. Okay, so wording matters. So wording matters big time. So Rasmussen, or I'm not even sure if I'm saying that right, but this is something that I did find just doing my research. So this is true. This really did happen. So a reports poll that found strong support for the immigration freeze was worded this way. Do you favor or oppose a temporary block on visas prohibiting residents of Syria, Iraq, Iran, Libya, Somalia, Sudan, and Yemen from entering the United States until the federal government improves its ability to screen out potential terrorists from coming here? Contrast with that, and I'm not even going to try to pronounce that, another poll which asked, do you support or oppose suspending all travel by citizens of Iraq, Syria, Iran, Libya, Somalia, Sudan, and Yemen to U.S. for 90 days? So basically it's the same question, but worded extremely, extremely different. So regardless of your political views, these were two extremely, very different worded questions. So if we look at this, we have the way that they were worded. The second one was worded just very plain and simple. It was just very cut and dry. So basically, do you oppose it? Okay. And then the second one, it throws in potential terrorist. Okay. So they're trying to, the first question is just trying to scare you a little bit. And you could look at it as a good way. You could look at it as a bad way. You could look at it. There's so many different ways we could look at that first question. Okay. We don't know where they were going with it. All kinds of political views. We're not going to get into that, but two very different way of wording questions. So the first question is definitely wording bias. Okay. So the choice of words may be loaded in some way to unduly favor one response over another. So this is also called loaded questions. And we don't know what way that first one, we don't know what way they were trying to sway the person, okay? But they were definitely trying to sway in one way or another, obviously. Then we have undercoverage bias. So it occurs when the sample is not representative of the majority population. Okay, so it'd be like example, polling the country versus Yadkin County, okay, or polling the seniors versus polling the school. We're going to get very, very different opinions there. And under coverage bias, you know, we can look at that several different ways, but under coverage, you know, and that's how, like, in a lot of these instances, no matter what we're talking about, whether we're talking about politics or they're talking about the coronavirus or anything out there, whether marketing, if they're wanting to try to sell you something, they can poll a certain group of people to make their product or anything that they're trying to sell you look favorable. So just keep that in mind. If you see a statistic, you may want to research it and think, okay, who are they polling? What group of people did they ask to get these statistics? Did they poll an accurate group of people or an appropriate population for this? Are these true statistics, or did they just poll a certain population? Okay, so just think about those type of things when you're looking at statistics. Okay, our next bias that we're going to talk about is response bias. So response bias occurs when the survey respondents are reluctant to admit the truth. Okay, so this is also called social desirability. So it happens when surveys aren't confidential or people just want to give the morally right answer. So it could be asked something like, have you ever smoked in your life? Or have you ever done drugs? Or do you always stop at a red light? Or maybe like this day and time, like, do you always wear your mask when you're out in public, or do you wear your mask the right way? So something that's like being asked like face to face, if the survey isn't confidential, like people just want to give like what people think that they want to hear. Okay. All right, so then we get into non-response bias, and some of these sound very, very similar. So like response bias, non-response bias. So non-response bias occurs when an individual is chosen to participate, but does not. Okay, so this happens, and this one seems, to me, this one was always kind of like the hardest one to understand. But it results when respondents differ in meaningful ways from non-respondents. So they might request things like an email address, which will keep some people from responding because they're afraid of spam. So if you've ever done like the little surveys or like the fun little things like on Facebook or Twitter where you do like the little quizzes, like, you know, which Harry Potter character are you? And then it's like, enter your email address to get your result. Well, then you're not going to do it because you don't want to get all these spam emails. Another example is the type of question like this, okay? So, what did you think of President Trump's State of the Union address? And then these are your answers. It was great. It was good. It was better than past presidents. Well, some people aren't going to answer that because they just don't like President Trump, and they think, well, I'm not going to answer that because I didn't like it at all. Or they just plain didn't like his speech. So, there's not an option for them to answer. So, it's not going to be an accurate representation of like what they really thought of his speech, because those are not good questions or they're not good answers for the question that's being asked. So this would be non-response bias. So then we get into voluntary response bias. And this occurs when people are asked to give their opinion and they self-select, okay? So this would be, a lot of times what happens is this overrepresents individuals who have very, very strong opinions. So this would be like calling into a radio station, or a lot of times you'll see like news stations will do this, like on Facebook or Twitter. They'll do a poll and people would answer a poll on there. And a lot of times people who don't care either way, like they have an opinion, but they don't care enough to actually answer the poll. But people who care a lot are really going to answer. And those topics would be obviously like the president, or what they think about the pandemic, what do they think about wearing the mask, or, gun control, abortion. Those are some really hot topics that people are going to answer about. Okay, so naming that bias. So in October, CNN, and these are true things that have actually happened. So I tried to incorporate some real things that have happened, so we could talk about it. So CNN conducted a telephone poll to project who would win the 2020 election. So these were real results that actually happened. Biden was projected to win, and he was favored 54% to 42% Trump. Since this was a telephone poll, people could choose not to participate. Either they didn't answer, or they just, maybe they answered and maybe they hung up, or maybe they didn't know. So they, obviously they didn't choose to answer. So this would be non-response. Okay. All right, so WXIIs conducted a Facebook poll to see if people approved of how Governor Cooper was handling the pandemic and lockdown of the state. So obviously people have very strong opinions of Governor Cooper. They have very strong opinions of the pandemic and of the lockdown. So they're definitely going to give their opinion one way or the other. They either really, really agree with it because they may be scared of lockdown, or they just love Cooper and his politics, or the opposite. They hate Cooper and his politics, and they want to be out. They want to be doing things. So this would be a voluntary response. Okay, so 1075 KZL had one of the, and this one, I'll be honest, I made this one up, but it could happen. So 1075 KZL had one of the DJs standing outside the mall asking people if they always wore a mask when in public. So people want to say they want to do the morally right thing. So this would be response bias, because they want to say, yes, of course I'm wearing my mask. And then healthcare workers at a hospital from the COVID unit were polled and asked if they thought it was important to wear a mask in public. And this one's going to be under coverage, because they are probably seeing like the sickest of the sick, and they're going to think that it's important to wear a mask. More than likely, it's going to be a high percentage of the nurses. They're going to say, yes, it is important to wear. Okay. So why is this question biased? So do you think students and teachers should do remote learning because getting COVID-19 is really dangerous to their health? Okay, so the fact that we're saying is really dangerous to their health, that is adding in word bias. And can you rephrase it to move the word bias? So if we want to rephrase it, we would just say, do you think students, I'm going to abbreviate a little bit here, students and teachers should do remote learning? Okay, just keep it plain and simple. We're not trying to sway them one way or another. We just want to know, should they do remote learning? Okay, and then kind of on the opposite end of that, do you think students and teachers should be in school full-time because students' learning is important and they are struggling with remote learning? So once again, should they be in school full-time because learning is important and they're struggling with remote learning? So we're trying to get them to answer that they should be in school full-time. We're trying to sway their answer. So this, again, is wording bias. So it's word bias. And can we phrase it? And so we would just say, we're going to keep it plain and simple. Do you think students and teachers should be in school full-time? And we just want to leave out any words that try to sway people one way or the other, to leave out that bias.